So you're thinking about building a battery bank and you're gonna need more than one battery because one is just, not enough. But how do you connect multiple batteries? Do you do it in series or should I use parallel? What's the difference? Is there pros and cons to each? How do you actually do that? I had all the same questions. Let's go find out how it works. Hey, thanks for joining me. Welcome to the channel. Earlier this summer, I did a couple of videos that got a pretty fair amount of traction, and one of them was kind of a DIY solar generator project, and I'll put a link up here if you're interested in checking that out. And then another one that also got a lot of views was kind of how to determine how much battery capacity you need. And again, I'll put a link up there if you're interested in checking that out as well. So in this video, we're going to do something a little bit different, but it's kind of a follow-on to that sort of how-to series. And this is a topic that seems to trip a lot of people up. We're going to talk about connecting batteries like these two right here from PowerQueen in series or parallel. And we're going to talk about kind of the what does that mean, the why would you do one versus the other, and then finally, the how do you actually do it. So let's just kind of dive right in. I'm going to try to distill this topic down into as simple terms as I can and make this easy to digest. So hang in there with me. We'll find out how well I do. By the way, while this is not technically a sponsored video, I do want to thank the folks at PowerQueen. They did not pay me to do this video. These were actually sent to me for another video that I did previously, and but I wanted to add some content using these products as well, and PowerQueen provided them. So thanks to PowerQueen. It's good stuff. So let's talk about the what. What the heck does it mean when we say we're connecting batteries in series or parallel? Let's talk about parallel first. When you combine batteries in parallel, you connect the positives to the positives and the negatives to the negatives. And when you do that, you are combining each battery's amp hour capacity, but you're keeping the battery voltage unchanged. So if we connected two 12.8 volt, 100 amp hour PowerQueen batteries in parallel, we would have a battery bank that has 200 amp hours in capacity being delivered at 12.8 volts, or we also say that as 12 volts nominal. And in contrast, when we combine batteries in series, we are connecting the positive to the negative, and then the next positive to the negative, and so on. And when we do that, we are combining each battery's voltage, but leaving the amp hour capacity unchanged. So if we again connect our two 12.8 volt, 100 amp hour PowerQueen batteries in series, we'll have a battery bank that still has 100 amp hours in capacity, but now it's being delivered at 25.6 volts and is what we would call a 24 volt nominal configuration. So what does that mean for total capacity? To calculate capacity, we really want to do that in watt hours. And to get watts, we simply multiply volts times amps equals watts, or volts times amp hours equals watt hours. So taking our 12 volt configuration example, we multiply 12.8 volts times 200 amp hours and we get a total of 2,560 watt hours. And notice that for our 24 volt configuration, we're multiplying 25.6 volts times only 100 amp hours and we get 2,560 watt hours. So the total capacity in both configurations is exactly the same. So what if I wanted to increase the total capacity of my 24 volt system and just add a couple of more batteries into the mix? Well, if I connect all those batteries in series, we have to add up all the voltages, and we're going to end up with a 48 volt nominal system, not a 24 volt nominal system. So how do we do that? So in this case, we'll need to combine series and parallel connections in the same system. So first we'll put two of our 12.8 volt batteries in parallel to create a 12.8 volt 200 amp hour configuration. And then we'll take our other two batteries and we're going to do exactly the same thing, creating two separate 12.8 volt 200 amp hour battery banks. And then finally, we can connect these two different banks together in series to create one 24 volt nominal 200 amp hour battery bank, giving us a total of 5,120 watt hours while still maintaining our 24 volt nominal configuration. So hopefully that part makes sense. That is kind of the what of the series versus parallel. Now let's talk about the why. Why would you do one versus the other? So obviously there are pros and cons to 12 volt configurations versus 24 volt configurations, or even 36 and 48 volt configurations. We're going to kind of just focus on 12 and 24 for the sake of this discussion to keep it simple. So let's look at 12 volt systems to start with. So in terms of benefits of the 12 volt system, 12 volt systems are directly compatible with 12 volt appliances. So you don't need any converters. You can just connect those 12 volt appliances right up to the system and everything works. These kind of systems are pretty simple and easy to deploy for relatively small solar systems, usually up to, when you're dealing with maybe 600 watts of solar input or less. And finally, another benefit of 12 volt is you can use pretty easy to find 12 volt AC inverters to convert that 12 volts DC into 110 AC. Now, of course, there are some disadvantages to 12 volts. So first of all, because 12 volt systems will produce basically twice as much current or amperage at the same watt level of output, you have to use twice the gauge of wire in order to move the electricity through the system. And that can get, depending on your situation, that could get very expensive. And because 12 volt systems have 2 times the current of a 24 volt system going through the wires, there's the resistive impact on the efficiency. And so they're going to tend to be less efficient than a 24 volt system. Now let's talk about the benefits and disadvantages of a 24 volt system. So one of the obvious benefits right off the bat is that a 24 volt system will produce half the amperage than a 12 volt system to produce the same amount of power. And half the amperage means you can use a lot less expensive cabling, especially for long cable runs, than you would have to use in a 12 volt system. And that, again, can be a huge cost savings. Another benefit to 24 volt is that it more easily supports larger solar installations than does 12 volt, using the same charge controller, or as the case may be, fewer charge controllers if you happen to have more than one in the mix. So for example, I have a Booj RV 40 amp charge controller, and in 12 volt configuration, it can only support up to 600 watts of solar input. But if I change that to a 24 volt system, I can have up to 1200 watts of solar input. And if I go to a 48 volt system, I can have up to 2400 watts of solar input. Now let's look at disadvantages. So first of all, you're going to need to make sure that you have a 24 volt inverter. Now this is not really a disadvantage, it's really just a consideration. But 24 volt inverters are a little less easy to find than 12 volt AC inverters. But if you're buying these online, they're essentially just as easy to buy as 12 volt inverters. So like I said, it's not really a disadvantage. Another disadvantage of 24 volt is that if you have to support 12 volt appliances, you will need to get some kind of a step down converter to switch that 24 volts back down to 12 volts in order to support these 12 volt appliances. And there is some loss in that process. So you do lose some power in that conversion process. So be aware of that. But the cost of the step-down converter itself is fairly minor, so it's not generally a huge deal. Now, another possible disadvantage of a 24-volt system is if you're putting this into an RV or a van that has got a 12-volt system in it, and you want to be able to charge your 24-volt battery bank through that alternator, you won't be able to do it directly. You'll have to add some additional components there, a DC to DC converter to take that 12-volt system to step it up to 24 in order to charge your 24-volt battery bank. So how do you decide which configuration is right for you? It's going to be dependent on how you want to use the system. And an easy rule of thumb that is commonly used to make this decision is to understand what is the total power needs of everything that you want to run. And if those power needs are under 3,000 watts, then you can stick with a parallel battery bank system, and that should work for you just fine. Now, if you need to go over 3,000 watts, up to about 6,000 watts, then a 24 volt actually starts to make more sense. And if you're going to go over 6,000 watts, then you probably should be looking at something like a 48 volt system. All right, did any of that make sense? I hope it did. I'm sure there are things that I didn't cover, especially in the pros and cons or the benefits and disadvantages. And if you've got some experience in that area that you want to share and you think there are some things that we could add to that list, please comment in the comments below. I'd love to read kind of more about what your thoughts are on parallel or series connections and how they apply to various situations. All right, enough talking to you at the desk. Let's get over and actually connect two real batteries in series and parallel connections and see how it actually works in real life. All right, whenever you're going to connect two batteries in series, you really want to make sure that they are, first of all, same manufacturer, same capacity, basically the same age, same number of discharge cycles. You want them to be as identical as you can possibly get them. And that ensures that they have the same BMS and the same cycle life and all that sort of stuff. And so that you don't wear one battery more than the other when you're going through the charge and discharge of normal use. So to balance them, I'm using a lithium iron phosphate specific charger here, a 12-volt charger, to balance them individually. So I ran this one. This one just shut off. You can see I've got a little green LED down here that says it is basically finished charging. I'm going to do the same thing for the battery on the left. And then after that, they should pretty much be ready to go. All right, battery number 2 is now topped off. It just literally just took a minute because these were basically already full. So I just wanted to make sure that they hadn't discharged at a different rate in the time that they've been on the shelf. So they're pretty much ready to go. I'm going to go ahead and set them over where I intend to use them. All right, when wiring batteries in parallel, you're going to want to make sure that your cables are exactly the same length. So I took some care here to try to cut these exactly the same length so that there's exactly the same amount of resistance on these wires. And we're going to wire the negative side to the negative side and then the positive side to the positive side. And in so doing, we're going to take a 100 amp hour battery and a 100 amp hour battery, combine them, creating a 200 amp hour battery array and or battery bank, and they are going to be still outputting 12 volts. And then I'm going to use a ratchet here that's got a composite material around all of the metal so that there's really no way for this to ever contact two terminals and cause a short. So these are, I highly recommend tools like this if you're going to do this kind of work. But I'll put a link to this in the description below if you haven't ever seen anything like this, but definitely worth looking into. They're not very expensive. So we don't want to super tighten these, but I want them to be firm. Definitely don't want to over torque these. I am getting 13.79 volts. So it's pretty good resting volt for these batteries, fully charged. So let me go ahead and make the connections here, and then we'll get this AC inverter up and running, and we are going to run a capacity test with this AC inverter on these batteries to see if we are getting anywhere near the 2,500 watt hours or so that we should be able to get out of this as a 12 volt 200 amp hour battery system wired in parallel. So let's just check that out. The other thing I'll point out is that to ensure that current is being pulled evenly across the entire battery array, I've got the negative on this battery and the positive on this battery. So that way I've got the full cycle. Now what you typically do if you had multiple batteries here, like 4, you'd use the negative on one end and the positive on the other end, rather than taking, because I could hook it to this positive and it would work, but it will exercise this battery a little bit more than this one, and I would like to even that out as much as possible. And again, I'm making sure that none of these little wire terminals are kind of getting cocked on there. I'm making sure they all lay flat, so you kind of have to move them around if necessary, just to ensure you're getting as much surface area contact as possible. Now here, if I were to engage the breaker so that it would allow the circuit to go through, as soon as I touch this pole, I would get a spark as the capacitors in the inverter are charged. But in this case, I'm not, because I have the breaker currently tripped. So I'm going to go ahead and put that on there. There we are. Okay, so that's good. I'm going to go ahead and cap that. Now when I turn this on, I now have charged the capacitors in here. The AC inverter is now connected. And there we go. I do have my minus lead, my negative, going into the Smart Shunt so I can monitor what's going on from the app. Now we'll do a load test and see how much capacity we draw out of this battery bank. We're going to let this run, and this is going to continue to count the watt hours as we run. We are going to get some loss out of the inverter. The inverter is going to, by the way, probably consume somewhere around 10% of that number because of the conversion process, so that is expected, and we'll just see how it all shakes out. All right, let's do a quick calculation here. If we were at 12.8 volts times 200 amp hours, that gives us 2,560 watt hours. So let's multiply that by let's just do 0.9. Let's just say we have a 90% efficiency on the AC inverter. I'm not sure if that's true or not. That should net us somewhere around 2,300 watt hours.
2 hours later.
All right, we're getting the low voltage cutoff alarm from the inverter. So I'll go ahead and turn that off. So that is super annoying. It says 2,351 watt hours is what that says. So that is actually pretty much right what we calculated. We said somewhere in the vicinity of 2,300 watt hours. I think we've got full capacity using a parallel connection on these Power Queen batteries. So now we're going to have to reconfigure this and do a serial connection and see what that looks like. All right, so when we did the parallel connection, we did positive to positive and negative to negative. And we saw that that all worked fine, and it left us with a 12.8 volt battery bank, and it doubled our amp hour capacity to 200 amp hours. Now, if we're going to do a series connection, that means instead of hooking positive to positive, we're going to go negative to positive, and then we'll use the positive negative leads off one end. And that will, instead of doubling the 100 amp hour, we will remain at 100 amp hours, but we will effectively double our voltage to 24 volts. Now that presents a problem because this is a 12 volt inverter. So we cannot use this inverter in a series configuration with these batteries. Since we're going to have a 24 volt battery system, we're going to need a 24 volt inverter. So this is a 2500 watt 24 volt inverter that I picked up on Amazon. This is from a company called XYZ Inverter, and it's fairly inexpensive, and it's just got a little display on this side here, and we're going to see it'll show the voltage and then the output, and we'll find out how kind of all that works when we get it installed. But I'm going to have to reconfigure this just a little bit in order to accommodate this larger inverter here. So let's go ahead and do that, and we'll get this XYZ 24 volt inverter installed and then hook up these batteries in series.
2 hours later.
I did prepare a little miniature cable here. This might be considered a flexible bus bar that's going to go across these two leads right there. So let me go ahead and put that in. I'm getting 27.65. So that's what we want to see. All right, I can go ahead and power the AC inverter and then turn it on. And since you can't see the other side of the inverter from that camera, I'm going to just get a little bit of video with my phone, and we can see here that we're picking up 27.7 volts off of the series wired battery bank, and we are outputting, or capable of outputting, 123 volts AC. So very cool. All right, now just to prove to ourselves that we are going to get roughly the same capacity out of this series connected battery bank that we got out of it when it was in parallel, we're going to redo that same load test with the space heater. And we'll check back when it's done and see how many electrons we caught. All right, our discharge test has completed. The AC inverter just kind of alarmed, gave me its low voltage alarm. So we need to go find some place to plug this in so we can see what it reads. All right, you can see we got 2,407 watt hours. So that's actually a little more efficient than the 12 volt inverter was. All right, now the last thing I want to point out is if you want to top these off with an AC charger, you may remember that I did that before I did the initial connection, but that was a 12 volt AC charger. And this is a 24 volt system in this configuration. So to use that charger, I would have to take these apart. So it's handy if you have a 24 volt battery bank set up to use something like this. This is a 24 volt charger. This is a product that Power Queen makes, and it is specifically designed for, you look at it here, output is 29.2 volts, but it's designed for a 24 volt battery configuration. And it's very simple. You just plug it in, you clamp on the alligator leads, just like I did with the 12 volt, and it has LEDs. So the first one flashes when it's charging, and then when it is, if it's got a fault, the middle one will come on, and then when it's done, the bottom one will come on. So I just wanted to make sure you understood that there's a distinction between these chargers, and you don't want to try to charge a 24 volt battery bank with a 12 volt charger, or you don't want to charge a 12 volt battery by itself in a 12 volt configuration with a 24 volt charger. You do need to make sure you get that right, just like you need to make sure you have a 24 volt inverter with your 24 volt system, or a 12 volt inverter if you're using a 12 volt system. So if you found any of this information useful, I'd really appreciate a thumbs up on the video. It really does help. And if you're not a subscriber yet and you think you might like this kind of content, because I'll be doing more of this stuff in the future, please consider subscribing as well. Anyway, so that's about all I got for you in this particular video. I do hope to see you in the next one. I've got more coming. And until then, have fun out there.